Saxon Algebra 2, Lesson 5, greetings to my students. A special shout out today to students who are watching these videos but not otherwise meeting with me or arranged in a formal class situation, people who have found me on YouTube. I'm getting several questions from people in your situation. What if I'm using second edition? As opposed to me, I'm using third edition, right? Is that going to be a problem for students who are using a book that's second edition? Kind of it is, but probably not for a while. I believe, I haven't studied this rigorously, but I believe that the difference between the second edition and the third edition has mostly to do with the order in which the lessons are presented. If you look in the front, there's a table of contents that lists all of the lesson numbers and their topics. And I think if you were to compare the table of contents for edition 2 to edition 3, you would find some differences. So at some point, I'm going to say, and in lesson 24, we're going to talk about fractional equations, and you're going to look at your 24 and go, no, that's not what it is. It's talking about negative reciprocals. So then you would have to go in and you would have to figure out where my lesson is in your book, and it could be a little bit of a mess. So if you want to use second edition, it'll work for a while until it doesn't work anymore, and then it might make you crazy. So if you can track down a third edition, by all means do it, because it'll save you a little drama. But on the other hand, if you can only have a second edition, don't stop studying, just make it work. Okay, guess what? I'm done with that. Lesson 5 is about word problems. I know, buckle in. We're just going to review the things that we did last year, so there's nothing new in here, but you know, word problems are always a bit of a challenge. Word problems are hard, you guys, because normally you're just taking numbers and rearranging them, right? Your problem starts with numbers, and then you have to work on it, and your answer is going to end up also in numbers. That's less dramatic. But word problems start in the world of words. And before you can even start working on the numbers, you have to translate from words to numbers. Then you have to work on it and get your answer in numbers. And then usually you add some words to it too, but that's just in the answer. So yes, word problems are hard because they require more of your brain to get involved in solving it. The only way we can review this is just to dive in. Are you ready? The first one is one of those that gives you a headache every time you read it. Twice a number is decreased by 7, and this quantity is multiplied by 3. The result is 9 less than 10 times the number. Oh my goodness. I just read it and go, ugh, I don't even know what I'm saying. Here's the secret. Twice a number is decreased by 7, and this quantity is multiplied by 3. Okay, we can figure all that out. We'll do that in a minute. The result is 9 less than 10 times the number. The secret is to forget about this number and write this as an inequality first. That is the best way to do it because our brains tend to want to set these up incorrectly. And so that's the best way to keep yourself from falling in that trap is first write an inequality. And I will tell you that a lot of students, many of them with male chromosomes, consider that a waste of time. I don't need to write it twice. I'm not going to write it the wrong way and then fix it. I mean, okay, but just do so at your own peril because this really will help you keep from falling into the mistake trap. Okay, twice a number. All right, we remember this whole thing of the number is going to be n, 2n equals twice the number, right? Is decreased by 7. And this quantity is multiplied by 3. I could put the 3 here, or I could put the 3 here. I'm going to put it in front, but if it helps you just to sort of do it in order, that's fine. Twice a number is decreased by 7, and this quantity is multiplied by 3. All right, that's reasonable, right? The result is number that I'm ignoring less than 10 times the number. Okay, so we've written an inequality. We know there's a number that's going to balance this. It's going to change it from a minus sign or an inequality to an equal sign. That number's in the problem. I can look at it in a minute. The more important thing is to look at this and figure out how we want to use that number to restore balance to the force, the equation. So what we do is we look at this and ask ourselves, which side is bigger already? This side is bigger, right? That's what this means. This is less than this. So this is the bigger side. So that means we can take our number and we can either subtract it from the side that's already bigger, or we can add it to the side that is less, right? I should be saying greater than and less than. Okay, so this helps us understand how to balance our equation, because right now it is not in balance. So what I always do, you guys, is I always adjust on this side because I have room to write. So I am ready now. I say, okay, this side is bigger, so I'm gonna subtract that number from this side. That will turn it into equals. And I go back to the problem and say, okay, what is the number? And we see it as the result is 9 less. So I'm gonna subtract 9, and then I'm gonna rewrite it. That, people who don't like to write things over and over, is a way to follow the steps that I'm suggesting to you, but not cause you a lot of extra writing, all right? I write it as an inequality, I figure out how to balance it on this side, I change it, and then I move that from a less than to an equal sign. Now I'm ready to solve. Please remember to write an inequality first. It'll make this so much easier for you. And you know, that is my goal. I don't want you to lose your mind. I want you to learn math, but I don't want you to freak out. Okay, now what do? Well, let's distribute, right? Whenever I see parentheses, I don't want them. So now I have 6n minus 21 equals 10n minus 9. Cool? Add like terms would be a good next step, but there aren't any matching terms on the same side. So we're ready to swim our fishies, right? Let's see. I think I would like to subtract the 6n. So I'll end up with a positive n number. And that means I have to add 9 to swim the plain number fishies the other way, right? We started by swimming the n's over here, and then we have to swim the plain number fish, so it'll be all right. All right, this gives me minus 12, well, I don't love that, equals 4n. That looks painless. And we get n equals minus 3. And at first I think, oh no, does that make sense? Because sometimes word problems, negative numbers don't make sense for them. But this one does, because there's no ducks on a pond or elves in the forest. It's just numbers, right? So it's perfectly fine to have a negative number. And that's the right answer. Yay! All right, we're ready for the next one. Let's see how many there are in this lesson. 1, 2, 3, 4, 5. All right. So don't worry, this won't be an hour-long lesson. I mean, I could always drag it out, right? I could tell stories. I could get distracted with my pets. Okay, number 2, ready? The number of ducks on the pond was doubled when the new flock landed. Okay, so there were some ducks on a pond. That the number of ducks in the first place will make that n. Some more come and the number doubles. Then 7 more came. The resulting number of ducks was, number that we're going to ignore, less than 3 times the original number. How many ducks were there to begin with? Okay, so n is the number of ducks to begin with. So let's read this. The number of ducks on the pond was doubled when the new flock landed. So there's double. Then 7 more ducks came. The resulting number was less than 3 times the original number. Okay, I ignored that number again and I just wrote everything else to match the words. Let me do it again. The number of ducks on the pond was doubled when the new flock landed. Then 7 more ducks came. The resulting number of ducks was less than 3 times the original number. right? So now we look again, we see, okay, which side's bigger? This side's bigger, this side's smaller, right? That's what, no, I said that wrong. This side is smaller, this side is bigger. So once again, if I want to adjust on this side, I need to subtract, right? I need to make this side smaller because it's already bigger. All right, the resulting number of ducks was 13 less. So I have to subtract 13 from the larger side in order to get these to be equal. Cool? All right, guess what? Now all we have to do is solve that. We don't even have to distribute this time, right? Let's move the 2n this way. And let's add the 13 this way, right? Those cancel, and we get 10 equals n. That's it. Wait, how did I get it wrong? Oh, I see what I did. It should be 20, right? I said plus 13 and then I wrote plus 3. No, that's not right. I forgot to write the 1 down. So now when I add them together, I get 20. That's the right answer. Right. Don't be like me, kids. Copy the numbers correctly. Okay, so that's how many ducks there were on the pond in the first place. And we can write n equals 20 ducks. Right? It's nice to add a word. We're going from word to number, and then it's nice to add a word at the end. All right? Next one. 5.3. The sum of negative 7 and 6 times a number is multiplied by 5. The result is some number less than 3 times the number. What's the number? Okay, once again, we see that it's going to help us to write an inequality first, and then we'll fix it. The sum of negative 7 and 6 times a number is multiplied by 5. This time I'm just going to write the 5 down here because that flows with the words. The sum of negative 7 and 6 times a number, sum means add, negative 7 plus 6 times a number is multiplied, quantity, times 5. The result is big number less than 3 times the number. The sum of negative 7 and 6 times a number is multiplied by 5. The result is less than 3 times the number. Okay, so once again, and these are all just working out this way. We could have them where they're greater than, but all of these have been less than. So that tells us that this side is smaller, this side is larger. If I want to adjust this side, then I'm going to have to subtract. And the number, I go back and look, what is the number? It's 332. It's a big number. But now it's equal. So now I'm good to go, right? Okay. Distribute. No, that's a minus sign. Okay. Well, let's subtract 3n from both sides. And let's add 35. These numbers are going in crazy directions. I'm not sure how I feel about it. But let's see what happens. Okay, that cancels and that cancels. I'm happy with that. This is going to be minus 27n, right? Equals, this is a minus sign. So we're taking 332. And we're minus 332, and we're adding that. So what I can do is I can turn this into a subtraction because I want to find the difference between those two. I know that my answer is going to be negative because the negative number is way bigger, but the 35 has to be subtracted from the 332 in order to find the difference between those two numbers. 297. Okay? I would panic at this step, but I already know that 27 goes into 297 cleanly. I'll show you. It goes in once, and it goes in once again. Oh, okay, so it's going to be negative. This is gone. N equals, this reduces to negative 11. That's a happy result, isn't it? With all those big crazy numbers. I thought we were gonna get a mess, but we didn't. Thank you, John. Thank you for being cool. Remember that showing your side calculations is a part of the problem. You don't want to throw those out or do them on a separate paper or act like you're ashamed of them. Some students who are super perfectionisty and don't like messes, I've encouraged them to like create like a calculations box, right? If it's really bugging you, Laura Rice, if it's really bothering you, create like a little separate workspace for yourself so that you don't feel like it's cluttering up your other calculations. But these are important, don't get rid of them or hide them or feel shame. Boys usually don't care about that. It's girls who are super, super, super neat don't like to have that clutter. All right, now we're going to move on to a slightly different kind of word problem. It is the frickin' formula model. Remember that there are two kinds of frickin' formula problems. Oh, by the way, the fancy name of them is fractional parts of a whole. Oh, fractional parts of a number, John's calling them. Now you know why I don't call them this. I think that's a really boring and confusing sounding name. Frickin' formula is much easier for me. We've got a group of something, the group of gumdrops on the table, and we're dividing it according to some attribute, the ones that are black. And then these are all the ones that are not black, because we don't want to eat the black gumdrops. We're going to give them to our brother who likes black gumdrops. All right, that's just an example of how this can work. The original group always represents the whole. So sometimes we talk about this in terms of fractions, where it would be 1 over 1. Sometimes we talk about it in terms of decimals, where it would be 1.0, or we can do percents. Okay, and then these are divided up into smaller groups. We use a diagram like this to fill in a formula like this. This is the total group, and this is the special group. Usually, this is always the of number. The is number can be either one of these special groups, whichever the story wants it to be. All right? So we take the fraction, and we have fractions associated with these. Let's make this 1/3 and this 2/3, right? Every story is going to have different fractions. So we use the fraction times the total group to give us the special group. All right? If we're using one that has decimals, we can just adjust the formula. But if we're using percents, remember we have to do it like this. We have to put the percent over 100. All right? All of this needs to go into your notes, your formula notes, right? Make sure you remember this. Oh, there's one more little bit. Sometimes we take a group of things. Here's your gumdrops. And your mom comes home from work that day and she says, you'll never guess what? There were 1 million gumdrops at the office today, so I grabbed a bunch of them for you. And in that case, our original group is growing. These we usually only address with percents. So this would be 100%. This would be 100%, the original group, plus what we call an increase, right? And the formula is exactly the same. P over 100 times of equals is. This scenario happens when our percent is greater than 100. This scenario happens when our percent is less than 100. Okay? So we get different stories. Remember, I like to call this the ice cream sundae and this the peanut or the toddler baby Jesus because it looks like he's wrapped in swaddling clothes, doesn't he? Right? There he is, sleeping on his side. Or it can be a peanut. This is an ice cream sundae. You've heard me say it all before. Although, you know, it is always a great story. This, to me, looks like a scoop of vanilla ice cream. I imagine it in a clear dish with a little foot on the bottom. And then this is the hot fudge dripping down. All right? If it's not toddler baby Jesus, then it can also be a peanut in its shell. You know how they have the lines on them? Like that Planters dude, you know, that dude that they use in their branding for Planters peanut? He's got a top hat and little, I think he's got a monocle, which is like the one eyepiece. It's really weird. Okay, so ice cream sundae, peanut, or toddler. It's not a toddler baby Jesus, it's just baby Jesus. Infant baby Jesus. All right, so we're gonna use this model to solve the last two problems, and then we shall be done. Example 5.4. Are you ready? I know I am. 1/5 of the clowns had red noses. Okay, just from that, our brain can go to this. Here's the clowns. This is obviously a fraction version, and we're dividing them into two subgroups. Red noses, and honestly, this is how you can always do it. Just say not red noses. Maybe they don't have noses. Maybe they have purple noses. Maybe they have, I don't know, anything, but they don't have red noses, so they're not part of our group. 1/5 of them had red noses, so that means we can always fill in the information. 4/5 did not, right? Because that has to add up to 1. If 30 clowns had red noses, okay, the clowns with red noses goes here. How many clowns were there in all? Put the X where the question is. All right, we remember that this, the first circle is the of. Whichever one of these we're interested in, that's the is. And here's our frickin' formula. The fraction version is the one we want. F times of equals is. The fraction comes here. It's the fraction associated with our special group. So we can set this up saying 1/5, that's our fraction, times the of number, which we don't know, equals 30. That's the is number, right? Our special group. All right, so that's how I start with the diagram. I figure out where my different parts of my equation come from, and then I plug them in. Notice there are 3 different numbers we could put in. John always gives us 2 of the 3, but he doesn't give us the same 2 of the 3. So we have to be ready for adventure. Now we look at our equation and just think in terms of algebra. How do we solve this monkey boy? Very often there's a fraction next to a letter. The best way to unravel that is multiplying by the reciprocal. We'll put this over 1 so it's in the fraction club. We have to match, right? This now cancels. 5 over 1 is 5, or 5 times 1 is 5. 1 times 5 is 5. This equals 5 over 5, and it cancels and goes away. Yay. So now we have our x by itself, and we get x equals 150, ignore the ones, clowns. That's how many clowns we have in all, which is way too many. Yay, that's the right number. Make sense? Okay, we have one more, and it is one of my favorites. I like the clowns with the red noses, even though I don't really like clowns. But let's do the last problem of the lesson. Example 5.5. 7/8 of the Tatar horde rode horses. Okay, John. This is the Tatar horde. Now, I'm not exactly sure that this is right, but the Tatars, I believe, lived on the steppes of what we now call Russia, the steppes of Siberia, the flat, open lands. And they had horses, and they were crazy, and they ran around tormenting the more passive civilizations of their day. 7/8 of them had horses. I don't necessarily have to draw this line perfectly in proportion to the fractions, but I like to kind of make it work. These are the ones that rode horses. Rode horses. So that means we can just figure out that the remaining 1/8 didn't ride horses. I don't know, did they ride scooters or donkeys? I don't know, it doesn't really matter. They just didn't ride horses. All right, that's what's going on in my head when I just hear that first line. 7/8 of the Tatar horde rode horses. And I know that this is the whole group, right? So that's the full group right there. If 140,000 were in the horde, how many did not ride horses? Aha, so John's tricking us. He wants us to find this number, not that number. He wants us to find out how many didn't ride horses. So now our 1/8 is going to be very important because that's the fraction that relates to the special group we're interested in. John told us originally about the ones that did ride horses. We don't care about them, but we want to know the fraction of our group, and their fraction tells us our fraction. So that's helpful. All right, so now we're looking at, we're still in fraction land. F times of equals is. Of is the original number. Is our special group, that's this. And the fraction is the fraction that relates to our special group. Okay, so we've got everything we need. I'm using this now to write an equation. The fraction is 1/8. The of number is, and I'm going to put it over a 1 just to make our lives easier. And then that equals the is number, which is x. Okay, so again, John's given us 2 of the 3, but he mixed it up and gave us a different 2, and he's been very kind because now we see that all the numbers are on one side, the x is by itself already, so we don't have to do a lot of algebra to make this come to its graceful end. All we have to do is take 140,000 and divide it by 8. So let's do it. We could reduce it, but my brain just wanted to divide. 8 into 14, it doesn't go twice, so it's only once. We write down an 8, we subtract, we get a 6, and I bring down a 0. Okay, 8 times 8 is 64. I know that, so that's too big. So it's looking like 8 times 7. 56, we subtract and we get a 4. Bring down another 0. Okay, now I'm happy because 8 goes into 40 evenly. And now I just have to carefully fill in the remaining zeros. Let's see, the comma would go there. So we get x equals 17,500 didn't ride horses. And because I love John, I will go the extra mile and write 3 words for him at the end of my problem. I don't like to write a lot of words because you know what? Once I translate from words to numbers and I work the numbers, I don't really want to go back to the words, but I'll do it for John. So I usually just slap like 1 word on there, but I wrote 3 for him because I love John. Okay, guess what? That's the end of lesson 5. We have tipped our toes back into the murky and alligator-infested waters of word problems. I hope you're feeling good about this. We are going to be working quite a few word problems this year, but we'll go slow and I'll do my best to make them, I was gonna say fun. For some people they'll be fun. For me they'll be fun, but they won't necessarily be fun for everyone. I'll make them manageable is what I'll do. All right, I'll try my best. They can't all be about the Tatar hordes because honestly, if they were, I would love every single one of them. Can't you just see these like wild men with like black hair? You know who I imagine? Wait, are they? Who are the dudes in Mulan? The original, the animated Mulan, you know those big creepy dudes that have the like glowing eyes and the big black beards and they murder the people in the villages and there's the whole little like teddy bear. It's a doll, I think, not a teddy bear. that Mulan finds. Oh, they're just horrible men. I think of them. That's how the Tartar hordes look to me. So, you know, if you haven't watched Mulan lately, you can think about it when you're doing your math. All right, guess what? Lesson 5 is complete. Well, it's complete for me. You have to go do your homework. Yay! I'll see you tomorrow for lesson 6. Goodbye.